Okay, a few more terms now. We should also know what an oxidizing agent is. It oxidizes another species. It accepts, in other words, removes electrons from the other species or another atom. And they get reduced because they gain the electron. Few electron or electrons. Remember oil rig rule, same thing. Oil rig. Oxidation is loss of electron, reduction is gain. Same thing here. If it gains electron, it actually gets reduced. But then by doing that, it's actually removing the electron from the other species. So it's oxidizing the other species, right? Reducing agents are just the opposite. It reduces the other species, donates electrons, and they get oxidized. Okay, so let's apply these ideas, right? Now you can see this is chlorine here. It's got a -1 oxidation state. Being an element here, it's 0 oxidation state. Fluorine 0 and -1, and you should say exactly what is the oxidizing agent, right? Sometimes people say the wrong side of the equation. Let's see. Now fluorine, that fluorine we're talking about F2. So F2 oxidizes the Cl minus. If you're not sure what to call this, chloride or chlorine ion, you better say Cl minus ion. Okay, that will be the easy way out. Ion to chlorine. So you have to be careful in how you describe this. Okay, chlorine gas. Okay, so you can even say Cl minus to Cl2. That'll be the easy way to describe this. So because of that, fluorine is the oxidizing agent. Hope that makes sense. Oh, one other thing. Fluorine here has got 0 oxidation state, and here it's F minus. So it is accepted the electron from the Cl minus here. Okay, see, from chloride ion it's accepted the electron, so that gets reduced from 0 to -1. With all that fundamental ideas out of the way, let's go into balancing equations, right? There are a few different types of equations that you'll come across to balance. A common one being when you are given two half equations and then you have to balance it, right? And there are a few different varieties in this as well. So we'll go through them. Now, as I go through each example, there are so many examples here I'm going to go through. Now, as I go through them, feel free to stop the video, pause it, try them for yourselves, and then continue to play. That will be the best way to practice these equations. Okay, what we call this is half equations. You have reduction happening in one half equation and oxidation happening in the other half equation, right? It is about being able to see what's getting oxidized here. So in this case, Fe3 plus is getting to 2 plus. Obviously this is gained 1 electron. So the first thing is to do for each half equation, find which particular atom is getting oxidized or reduced, and figure out by how much. And you know, by adding electrons you're actually cancelling the positive charge. You can also do a quick check, do the charges add up on either side. +3 minus 1 is +2, and that's +2, so that's okay. We've done that half equation, easy. Now I'm ignoring the state symbols. This may be aqueous. Okay, this aqueous, and this is still maybe aqueous iodine solution, right? Okay, so I'm going to ignore this state symbol for the time being, because we're only focused on the redox side of things. Okay, how to balance this redox reaction. Now, one thing to remember is first balance out the atoms that's getting reduced or oxidized. First get them balanced before you do the electron addition. Now in this case I didn't have to, because you got 1 of Fe ion on either side, so I don't have to balance it. But here you can see 1 iodide ion here, but there's an iodine molecule with two iodine atoms on it, right? So I have to balance it out first. Now as you can see, there is a two minus charge here. So this has to lose that minus charge, lose the 2 electrons, so plus 2e. Once you got the 2 half equations ready, now what I have to do is get the electron numbers equal on both sides. Let's have a look at the first one. Is copper metal getting oxidized to copper ion, 2 plus ion. So this is losing 2 electrons, so I'm going to put 2e here. And silver is getting reduced by gaining an electron, right? Check the charge is 0 here on this left hand side, 2 plus 2 minus 0. Okay, so the charges should be balanced on both sides as well. So it's a thing to check before you multiply this by 2. As you can see that 2 here, 2 electrons, so I have to match the number of electrons on both half equations. So I multiply this whole thing by 2, and now I'm ready to add them up to give an overall equation. So copper plus 2Ag plus gives you, electrons gets cancelled out, 2Ag plus copper 2 plus. Okay, so what's happening is the silver gets displaced from an aqueous solution. So if you think of this as a solid copper put in an aqueous solution of silver nitrate, say AgNO3, yeah, so silver being a less reactive metal gets displaced as silver metal. So you should be able to see this as a solid appearing on top of the copper. It appears as a coating on copper, shiny silver coating. That now is aqueous. So the summary is that copper getting oxidized to copper 2 plus. So the way to describe this is copper metal oxidized to copper 2 plus, right? The ion name for copper is also copper ion, right? Okay, so that's right. Silver getting reduced from Ag plus silver ion getting reduced to silver metal. So you can see the overall equation here. I've cancelled out the electrons, and then you can check if the charges tally up as well. In the overall equation you got 2 plus on the left hand side, which matches with that 2 plus on the right hand side. I forgot to write that here, reduced. This is a way of describing, but when you write an equation you need to show the electron numbers and make sure that you have the numbers balancing all these numbers, including state symbols if that's required. Okay, so as I said before, if it's acid condition, we can add H plus or water molecules as required. Okay, so if you look at the left hand side, you got -2 and +2. I'm just counting the number of the overall charges only. I'm not counting this any other oxidation states, just the charges I can see. Here is a VO2, there is no numbers here. So I'm adding that plus and this 3 minus, that gives me an overall charge of -2. +2, I have that here. You want to take away this water molecule for now, it's a bit confusing, right? Okay, so that's how we start, and let's get back to this, right? Okay, so we have -2 to +2 to go. So I'm going to add H plus ions. From -2 to go to +2, I need 4 H plus ions, right? Now if you add this, 4 positive plus 5 positive, take away 3 negative, now I have +2, which is the same as this, right? So I'm just trying to get the charges on both sides equal by adding 4 H plus. This way it's more efficient because you're doing the balancing hydrogen and oxygen atoms and the charges at the same time. This is the easy way. Okay, so you have the 4 H plus. Now you can see the charges are okay, but the hydrogen atoms on the left hand side, there is nothing here on the right hand side. That's where you need to add the water molecule, right? So then you can see that I have to add 2 water molecules here for 4 hydrogen atoms to balance. Now check the oxygen atoms, 2 oxygen, 2 oxygen. You can see that has actually sorted itself out. Now I'm going to get rid of the extra numbers. I hope it makes sense. You have the same charges on both sides by just adding that 4 hydrogen ion and the water molecules, the atoms of H and O, hydrogen atoms and oxygen atoms also balanced now. Okay, so now we're going to tidy this up. We have 2 electrons here, 3 electrons, so we need to get the number of electrons the same. Okay, now that's all sorted. We just have to get the electron numbers the same in both half equations. We got 2e here and 3 electrons here, so I'm going to multiply through the whole of that equation by 3 and this by 2 to get the electron numbers the same, right? So this now becomes 3 now become 6. 3 times 2 6. Now this has to be multiplied by 2 all the way through, so that now becomes 8. So I'm going to cross that out and put 8 here. We'll tidy this up in a minute. And then 2 here, 6 electrons now, 2, this becomes 4. And now I can cancel out these 6 electrons and now write the overall equation. 3 is Zn plus 2VO2 plus 8H plus, giving 3Zn2 plus 2V2 plus 4H2. Oh, okay, right. So now you can see, check one last time, like 2 plus 8, 10 charge here, here's 6 plus 4, 10 positive charges. The charges balance out, check all the atoms, all done. Okay, don't worry, as you get to do more and more of this, you get more comfortable with this and you gain the speed. Okay, if you feel like, this is our next example, if you feel like that you can do this yourself, go ahead, pause this, try it, and then check in a few minutes again. We say this is acid conditions. Okay, acid conditions, unless I say otherwise, it's acid conditions, right? So that means you have to add H plus H2O as required. Okay, so I'm going to go ahead and go with this, balancing this equation. Okay, first thing is to check if the atoms oxidized and reduced are balanced. In that case, yes, but here it's not. Cr2, there is only one of the Cr3 plus ion, so the numbers of atoms and ions not balancing. I'm going to put a 2 here to start off with. About an electron here, because there's nothing else here, it's one ion, so the numbers are okay. So only this is 2 plus, it's losing an electron to become 3 plus, right? Okay, so the second thing to do is look at the oxidation state now. Okay, so you have plus 6 here. Now this is minus 14, and so collectively Cr2O7, I forgot to say there is a minus charge here. Yeah, there is a minus 2 charge here. Okay, I didn't mention that earlier, right? So minus 2 here, so minus 14, so this has to be plus 12, so you get an overall charge of minus 2 if you add these two together. So for 2 chromium atoms it's plus 2, 12, so each chromium atom's got plus 6. We don't have to worry about that, we just have to look at, okay, there are plus 12 charge here for both chromium atoms, and here you have plus 6 charge here. If you multiply these two, 2 times plus 3, you do this very carefully, make sure that these atoms, ions that is getting oxidized or reduced are balanced first. Okay, so this is balanced now, right? And you have 2 times 3 plus, 2 times 3 plus, giving plus 6 charge here, and you have a plus 12 charge on this one, so you now can see how many electrons that needs to be added onto the left hand side. So I'm going to add 6 electrons onto the left hand side. I'll add it here. Okay, now I'm going to look at the overall charge here, right, on the left and the right, because now I can see the oxygen atom here not balanced, so I may have to do this, right? H plus or OH. So I'm going to now look at the overall charge on the left hand side. 6 minus 2. Mind you, I'm not adding anything else, just the charges I can see. So I can see a total of -8 on the left hand side, and on the right hand side 2 times +3, I got a +6 charge here, right? So to go from -8 to +6, how many hydrogens I have to add to the left? Okay, so to go from -8 to +6, because I can only add H plus, I have to add it to the negative side to make it into +6. You can see from 8 to 6 to +6, -8 to +6. So as you can see, 8 plus 6 is 14. I need to add 14 H plus onto the left hand side. So I'm going to add 14 H plus on the left hand side. Now what I have, 14 plus and 14 plus, take away the charges I can see, which is that -2 as well, and then if you add them all up together, yeah, you now have +6 charge, which is what you wanted, right? Okay, so the charges are balanced now. Now you have to worry about the oxygen and hydrogen atom. As you can see here, one way, a quick way of looking at this is as you do more, you'll realize it's half of that. Let's do half of 14, 7H2O, because then you multiply that too. So hydrogen is straight away balanced. 14 hydrogen, done. Now check the oxygen. Do you have 7 oxygen on the right hand side? Yes, we do. See, when you balance the charges out, think in terms of charges, you actually balance out the hydrogen and oxygen, right? So now all we have to do is tidy this up. As you can see, 1 electron here, 6 electrons. I need to make the electron numbers the same. Now I've multiplied this equation by 6, so I can get 6 electrons on both sides, on the 2 half equation. Going to cross this out. Okay, so all I have done is tidy this up, written a whole overall equation right like that. Okay, all right. I suggest you pause this, you look through 2 examples over here and here, and now I think it's time for you to try on your own. However, I'm going to assume that you've done that and try this on a paper, check. I hope you're now checking. Okay, I'm going to just first of all go with identifying the oxidation numbers. As you can see, that's +7 for manganese there. So I have to add 5 electrons to this to get that to +2 on the right hand side, and then 1 electron here. Now as you can see, there is 4 oxygen atoms, nothing here. So, and this is acid conditions. Okay, so that means I have to add H plus to see the charges are okay on both sides. Now I'm looking at the overall charge here, so there is a minus here and +5 here, so there is an overall charge of like that, -6, and overall charge of +2 here. So from going from -6 to +2, I have to add 8 hydrogen ions on this side, as you can see, right? So 8 H plus ions. Now my overall charge has become 8 8 minus 6, 8 minus 1 and -5, that's +2 on the left now, which is equal to +2 on the right. So the charges are okay. Now I have to check the hydrogen and oxygen atoms. As you can see, 8 hydrogen, so that means if I put a 4 water here, that will be balanced. Now check the electron numbers on both half equation. 1 E here, another one. So I'm going to multiply the whole of this by 5, and now I'm going to just have to add them up together. MnO4 minus. Okay, now that is the overall equation, right? You can also do a quick check on the overall charges, add them up, minus 1, 10, so 5 times 2 is 10 plus 8, 18, now minus 1, so 17 you have, and you have the 17 on this side as well. 5 times 3 is 15 plus 2, 17, so that's all okay. And check the oxygen and hydrogen atoms. This equation is now done. So let's have a look at this example here, where Cr2O72 minus ion gets reduced to this, and I put the oxidation states here, plus 6. This is the total oxidation states. This is 3 plus 2 times 3 plus is 6 plus, that is here. And for these two chromium atoms together, that's a plus 12 oxidation state there. So each of them has got plus 6. As you can see, plus 12 plus minus 14 for oxygen. So we have minus 14 for the oxygen here. The overall charge being minus 2 over here. Okay, so this has to be plus 12. So that's going to plus 6. So I put a 6 electron here. So up to that is the same as what we've been doing so far. Now I want to look at the overall charge on the left hand side. I'm only looking at the charges here, not the individual atoms and ions, right? So this species, this ion here has got a 2 minus charge plus this. So overall I have a minus 8 on the left, and on the right hand side I have plus 6 over here, 2 times plus 3, so minus 8 to plus 6. This allows me to decide how many H plus ions I have to add to the left. As I said, this is acid conditions. If I don't mention, you might assume that it's acid conditions, right? Okay, so we have to decide now how many H plus ions we're going to need. Minus 8 to plus 6, so that's 14 H plus ions. We've done similar things before. So then this now the charge, overall charge now is plus 6 as well, same as here. So we've balanced this. Now look at the hydrogen atoms here, 14 hydrogen atoms. So I'm going to put 7H2O. Remember, for acid conditions you have to use these two to balance the hydrogen and oxygen atoms. And also I'm doing the charge at the same time. It's useful to look at the charge, and if you balance the charge, the hydrogen atoms seem to balance itself out, right? So then 7H2, that's 14 hydrogen here, 7 oxygen, 7 oxygen. So that equation is now done. So have a look at this one here. As you can see, zinc is losing 2 electrons, so this is easy, 2 electrons added. Now all you have to do is make the electron numbers equal. There is a 6 electron here, and you have 2 electron here, 6, and to make this electron number the same. So to do that, I'm multiplying this whole equation over here by 3 to get the electron number to 6. Okay, so that becomes 6. Now I can cross this and then just tidy up the whole equation underneath the overall equation. Okay, so as you can see, that's the overall equation that you have here. This species here, just to recap on what we've been doing so far, has been reduced. Okay, so this is the oxidizing agent. As you can see, this actually takes the electrons away from the zinc to make it to zinc 2 plus. So zinc is getting oxidized, and that gets reduced here. So this is the oxidizing agent, the whole species, that whole thing. More practice. Okay, so pause the video, see if you can balance this equation, 2 half equations yourselves, now knowing that this is acid conditions. Okay, I'm assuming that you have done that and you know you're checking. Do you see this oxidation state is -1 here, because you know this is peroxide, right? Times that by 2, so you have a total oxidation state of minus 2 here, and then you have 0 here because that's being an element. So that means this has lost 2 electrons over here. Also notice there is a hydrogen atom, 2 hydrogen atoms here. This being acid conditions, you have to balance it by actually writing H plus on the right. So adding 2 H plus ions on the right, so the 2 positive charges will cancel out this and they get 0 overall charge on the right hand side and also on the left hand side. By doing that, you can also see that I have balanced the hydrogen atoms. 2 hydrogen atoms, 2 hydrogen and 2 oxygen, 2 oxygen. So that equation, the half equation is done. Let's focus on this one. So that's plus 7 here and plus 2. So I need to add a 5 electrons here. Also notice this oxygen here, so that means we have to add H plus or water to balance that. H plus H2O, right? So then look at the overall charge to decide on how many H plus to add. So you have 6 minus here and plus 2 here. So let me try and add 8 H plus, right? Plus this, reason being 8 plus, so plus 8, and you have minus 5, and then you also have this minus 1 here, this minus 1, so that gives you plus 2 on the left hand side and plus 2 on the right hand side. Okay, I'm going to rub this off so you can see how I balance the charges by adding the H plus here. Also don't forget this oxygen, 4 oxygen atoms, and there is nothing here, so we have to add the water, and also hydrogen, no hydrogen here, so we need to add the water for this. As you can remember from before, you just half this and should be okay. So 4H2O, so 4 oxygen here balances. Now hydrogen is also balanced, right? And we just have to make the electron numbers equal. You got 2 electrons here and 5 electrons here. So going to multiply the whole of that equation by 5. So let me do this really quick. I hope you can follow this. 5, 5. That's now 10 electrons, and this is 10 hydrogen. Now multiplying this by 2, so that's 16 now. 2 here, and that's 10 electrons now. And then you have 2 Mn here and 8 H2O here, right? Okay, so tidy up. Notice that you got H2O2, so let me write this one first. 2MnO4 minus. Okay, so check the overall equation. I have cancelled out the electrons from both sides, so 10 electrons. So 10 electrons cancelled out, and this 10 H plus is still there. So we have 10 H plus and 16 H plus reduces to 6 H plus on the left hand side, right? 2 MnO4 as it is, so everything else is there. The water as well. So you have 8 H2O, that's here. Just beware of this hydrogen ions. Now count the number of atoms. Should be okay now. So 8 oxygen here. Hydrogen atoms 10 plus 6, 16. 8 times 2 is 16, so everything is all right. Check also the charges, should be okay. 2 minus plus 6 gives you an overall charge of plus 4 here. 2 times 2 plus 4, so that charge is okay. So one final check you can do when you balance the equation is the atoms, number of atoms and charges. When you actually arrived at the overall equation, it's worth checking that. Okay, so I suggest you pause this next example. Like I said to you earlier, practicing is the most important thing in this. So pause, practice and check, and continue to check the answer. So I hope now you can follow what I've done. The oxidation number is +7 for the Mn here. So I've added 5 electrons initially. Ignore that for now. So 5 electrons, 7 plus 5 gives you 2 plus. Okay, so 7 minus 5 gives you 2 plus. Then you look at the overall charge, that minus and that 5 minus, that gives you 6 minus on the right hand side, 2 plus on the right. So on the left hand side you have 6 minus. To go to 2 plus you have to add 8 H plus ions because it's acid conditions. So you have 8 H plus ions added. That leaves you with the required charge balance. Now you have 4 H2O to be added to balance the number of hydrogen atoms and the 4 oxygen atoms, right? So that equation is done, half equation. Remember, if some atom is getting or ion is getting oxidized or reduced, you need to balance that first. Now this is needs to be balanced by writing a 2 in front of it, and then say iodine is balanced on both sides, and you realize that it's 2 electrons, nothing else is needed. This is balanced. All you have to do is now make the electron numbers equal and write the overall equation. So I've multiplied the top equation by 2, so 16H plus all that species is rewritten here. I've rewritten that here because it's a bit messy here. So that's multiplied by 2 over here. This equation multiplied by 5 is written here. Then the electrons cancels up and from left to right, and then you have the overall equation. So in this case the oxidizing agent is that one, MnO4 minus, because it goes from +7 to 2 plus, so this itself gets reduced, so that must be the oxidizing agent. Pause, practice. Okay, so you can practice this and then check the answer. I've started doing this. Have a look here. This I'm going to show separately here. S2O3 is going to S4, so you have to put the 2 to balance this, because this is getting there is a change in oxidation state of that sulfur. So you need to make sure that that is balanced. So without that you're not going to get this right. So put the 2 in front of that. So now you got 4 sulfur here and 4 sulfur here to start off with. Now look at this. You have 6 minus for the oxygen, so this must be a total of +4. So for this is the total charge. For on each sulfur you got +2. That's why I've written here +2 for each sulfur, right? But then you have a 2 in front of this, so this is the total charge, total oxidation state of the 2 sulfur. Now times that by 2, you have a charge of +8 on the left hand side. Okay, so 2 times that +4 equals +8 here. It goes from +8 to +10, so bear that in mind. You may be wondering, what is the oxidation state of each sulfur atom here? 10 divided by 4 gives you 2.5. So sulfur's oxidation state in this case is 2.5. It can have fractional numbers. Okay, so check the number of atoms. 2 times 3, 6 oxygen atoms, 6 oxygen atoms. Sulfur is also balanced. So there is, in this case, there's no need to add the H plus or H2O, because you don't need any more hydrogen or oxygen atoms. Yes, balance already. So bear that in mind. You don't have to always add, although this is in acid conditions. Now for iodine, you can see that has to be balanced first by putting a 2 in front of that, and then you realize that it's 2 electrons added. Now there's nothing else needed. That equation is half equation is balanced. All you now have to do, because the electron numbers are equal on both sides, you just have to write the overall equation. That is the overall equation. Check the charges. 2 times 2 minus 4, and you have 2 minus and the 2 minus here. The charges balanced. Check the atoms as well. that's a balanced overall equation. Now that's done. Okay, so we're going to move on to the next example. Okay, resilience now. Practice makes it really strong in this area, because you have to use this redox idea in many different topics, so you will have to be really good in this. So practice this, check your answer once you're done. So it is acid conditions. So I've added the oxidation states of sulfur here, and then you notice that this is losing 2 electrons to become 4 plus, from 4 plus to 6 plus, right? So that's done. Looking at the oxygen atom, that's not balanced. So in this case, you have to add, okay, we can also look at the charges here, right? So 2 minus and another 2 minus, that gives you an overall charge of plus 4, because it's acid conditions. So we're going to, and on the left hand side there is no charge, SO2, right? So I'm going to try and add 4H plus, and the charges are okay. Then that means you have to add the water molecules on the left, because there's no hydrogen on the left. So 2H2O, let's try that. Then you can see 2 oxygen here plus 2 oxygen, so that matches, that balances the oxygen atoms here. Check the charges as well, that's balanced. 4 minus 2 minus 2 minus plus 4, that's 0 charge on the left. Charges balance out, right? So this equation's done, this half equation's done. Let's focus on this. Okay, as you can see, I've added 5 electrons for, it's going from 7 plus to 2 plus, and that is what you do first. And then you add this overall charge up, minus 1 and minus 5, that gives you an overall charge of minus 6. So it's going from minus 6, so considering just this, okay, I've added this one now. So minus 6 to go to plus 2 overall, you need to add 8H plus on the left hand side. That's why I've added 8H plus. Now because of that, I have to add 4H2O. We've done this before, so 4H2O, and that balances the oxygen atom. 4 oxygen, 8 hydrogen, and the charges also balances out by doing that. Okay, so these two half equations done. All you have to do is tidy this up and write an overall equation. Remember to multiply this by 2 and that by 5 to get the electron numbers the same. Okay, that is the overall equation. As you can see, I've written the 5SO2 here, 2MnO4 minus, and there is an excess of 2H2O, considering that 10H2O and 8H2O on the right hand side of the second equation. You have 2H2O left over on the left hand side. Then 5SO4, 2 minus is here, 2Mn2 plus, and there is a 4H plus excess here. It's 20H plus here, 16H plus over here. Take away, you get 4H plus left on the right hand side. So that is the overall equation. That's the last one in acid conditions. Next we're going to go into alkaline conditions. Okay, so try this, check once you tried. Okay, so I started by putting the oxidation numbers plus 5 and plus 4, and I added that 1 electron on the left hand side. Then looking at these two only, ignore that one, I added this just now. So if you look at this overall charge now, it's 2 minus, and there is no charge here. So then that means you have to add, because it's acid conditions, I added H plus onto the left hand side. 2H plus, that will cancel out this 2 minus. So if you do the charge first, and you can see you have oxygen, but there is 1 oxygen less here, and also there's no hydrogen here. So I have to add a water here to balance the hydrogen atoms. So that's now a balanced half equation. This half equation is easy to balance, right? So all you have to do is multiply this equation by 2 to get the electron numbers the same in both half equations and add them two together. Check. This is the overall equation. Okay, and now multiply this top equation by 2. I don't have to multiply this because the electron numbers become 2 electron. Just add them two together, you get this.